This video will cover the notes on difference and sum of two squares. So to begin, let's just kind of warm up and talk about what I mean by difference of two squares. So looking at part A, we're just going to simply use our PEMDAS and solve this problem. So 4 squared minus 1 squared would be 16 minus 1. So for part A, that would be 15. B, 5 squared is 25, minus 2 squared is 4. So 25 minus 4, 21. Then 6 squared minus 1 squared is 36 minus 1, so 35. If we keep going, D, if you look, D is just adding instead of subtracting like in part A. So D is 16 plus 1, so 17. E is 25 plus 4, so 29. And F is 36 plus 1, so 37. Okay. The point of all this is to kind of see, if you look at A, B, and C, what I'm doing there is I'm subtracting two things that are being squared in A, B, and C. And in D, I'm adding two things that are being squared. All right, now, there's something that's important, and there's a difference between subtracting two squares and adding two squares. So if you look at the next thing that's blank, it says write the prime factorization of each result above. So for part A, if we look at 15, the factors of 15 are 3 and 5. Then B, 21, 3, and 7. And then for C, we have 5 and 7. But then if you look at D, E, and F, 17, 29, and 37, none of those factor because those are all prime. Okay, so what I wanted you to see there is that if you have a difference of two squares, then you can factor those into two prime factors. But if you have a sum of two squares, then you can't factor those at all. Those are going to be prime. Okay, so just kind of as a follow-up for G and H, can you guess the prime factors for the following? So what I mean by that is, for G, I don't want you to do 12 squared minus 5 squared, 144 minus 25. Yes, you could do that, but I want you to guess looking at kind of the pattern that we saw from part A, B, and C. So if you look at A, is 15, and that's the product of 3 and 5. Now look at the numbers that I was subtracting here, 4 and 1. How do 3 and 5 relate to 4 and 1? Well, 4 minus 1 is 3, and 4 plus 1 is 5. Let's see if that same pattern continues for part B. 5 minus 2 is 3, and 5 plus 2 is 7, which are the factors of 21. And the last one, C, 6 minus 1 is 5, 6 plus 1 is 7, which are the factors of 35. So using that same kind of pattern for part G and H, we're going to actually do the prime factors. So that would be 12 and 5 are my two things that are being squared. So my first factor would be 12 minus 5, and my other factor would be 12 plus 5. So 12 minus 5 is 7, and 12 plus 5 is 17. So those are the prime factors. So that's a lot faster than actually solving out the problem and then figuring out the factors. So let's do another one for 10 and 3. So 10, and make sure it's a difference. We're subtracting two squares. So 10 minus 3 and 10 plus 3 are my factors. So if I were to find this, then the factors would have been 7 and 13. Okay, so the whole point of today's lesson is talking about the difference of two squares and the sum of two squares. And really the main thing that we're looking at is the difference of two squares, because as we already saw, if I'm adding two squares, so that means two numbers that are being squared. So if I have like a squared plus b squared, then we know that that's always going to be prime. That means I can't factor an a squared plus b squared. But if you do have a difference of two squares, a squared minus b squared, then that can factor. And so what we saw from part G and H is the way that's going to factor is the first factor is going to be whatever a is minus b, and the other factor would be whatever a is plus whatever b is. So what we're doing in this whole unit is factoring, and so this is just something that's like a really easy thing to factor that you don't really even have to think about. If you're subtracting two squares, then you're always going to have a minus b times a plus b. So let's try evaluating in example 1. So what I mean by evaluate is I'll find the factors and then actually multiply them out. So instead of sitting there and finding 103 squared minus 97 squared, that's really hard to do without a calculator. But now that I know my difference of two squares, I can use that pattern. So my first factor is going to be 103 minus 97, since these are difference of two squares. And my second factor will be 103 plus 97. Okay, so 103 minus 97 is just 6, and 103 plus 97 is 200, which now that's pretty easy to multiply. So that answer is going to be 1200. Okay, so I want you to pause the video and do B on your own. Okay, so if I find my two factors, again, this is a difference of two squares, so I can apply this rule. So that's 49 minus 51 times 49 plus 51. 49 minus 51 is negative, and that's fine. It can be a negative. 2 times 100 is negative 200. Okay, so the next thing that I want to make sure we understand is our perfect squares. Because if we're looking at a difference of two squares, we need to make sure we understand which numbers are squares. Okay, so we're just going to make sure that you have memorized this list. So the first perfect square is 1 squared, which is 1. Okay, so 1 is a perfect square. 2 squared is 4. 3 squared is 9. 4 squared is 16. Let's keep going. I want you to pause the video. I want you to do this on your own. See if you can do it on your own. Okay, so make sure you have written down all these perfect squares and that you memorize them. I know most people have up into 12, and then some people have trouble with 13 to 15, so just make sure that you've gotten those as well. So yeah, make sure you have these written down, and then just familiarize yourself with these numbers. Okay, so any other numbers are not perfect squares in this list. So only these in this list are perfect squares. Now, of course, you can go further, 16, 17, 18, but this is really the list we're going to work with. Okay, so now what I want you to do is write each expression as a square if possible. So, for instance, for part A, 25. 25, we already know, is a perfect square of 5. So what that means is basically what's being squared here. So the numbers will be pretty easy. So 25, the square root of that, what's being squared is x, or sorry, 5. And then x squared, what's being squared if I have x squared? Well, just x. So if I take 5x and that whole thing is being squared, that's what I'm looking for, is what's in parentheses that's being squared in each of these problems. So then if you solve that out, 5x squared is 5x times 5x, which you would then get 25x squared. Okay, so for part B, we have 81, which hopefully we know that the square of 81 is 9. Or the square root of 81 is 9, and then a to the 6th. Okay, so what is being squared if I have a to the 6th? Now, look over here for part A. What we're doing is we're having a power to a power. So remember when I did that, we multiplied that 1 times the 2 to get an x squared. So what are you multiplying by 2 in order to get this exponent of 6? So what that's going to be is 6 divided by 2 gives you 3. So it's the opposite of what we did in the last unit. Remember, we're factoring, we're dividing. So 6 divided by 2 is 3. Okay, so then if you multiply this out again, 9a cubed times 9a cubed would give you 81a to the 6th. Okay, for part C, 49, the square root of 49 is 7. Then m to the 4th, 4 divided by 2 is 2. N squared, 2 divided by 2 is 1. So then that is what's being squared. And then for part D, a little bit different. 100, the perfect square there is 10. A squared would be A. Now B. B does not have a perfect square. So only 10A here is being squared. And then that's being multiplied by B. B is not being squared in this problem, so it cannot be included in that perfect square. So just kind of a summary here, perfect square expressions have perfect square coefficients and even exponents. So as you can see in part D, 100, that was the coefficient, is a perfect square. And then a squared, what could be squared there, the 2 is an even exponent, so that's how it could be included in the parentheses. But b did not have an even exponent, so it was not included in the perfect square. So again, perfect square expressions have to have perfect square coefficients and even exponents. All right, so the whole thing of this lesson is we're factoring. So for example 3, this is the main part of the lesson. We're going to factor each binomial. Remember, a binomial means it has two terms, and if you look at all these examples, there are two terms. And we're going to use the rules that we learned over here, the difference of squares and the sum of squares. So if you're subtracting two things that are squares, that is, they look kind of like these example 2 things, and you're subtracting two of them, then you can apply this rule a minus b times a plus b. But then remember, if you're adding two squares, then that's going to be prime. That does not follow a rule. All right, so let's try an first example, part A. We have y squared minus 1 minus 1. So those are both squares. Y squared is y is being squared, and 1 is just 1. So applying that rule, a is the y. That's what's being squared. And then the b is 1. So remember, I'm looking for an a squared minus a b squared. So you're looking for what is being squared. So then that's going to be a minus b, so y minus 1, times y plus 1. And that's it. That's the answer. Okay, so let's try for part B. So for part B, the first thing is 25x squared. And we did this example right up here in example 2a. So what's being squared there, the a, is just 5x. Then you're subtracting your b, which what's being squared is 12. So that is a difference of two squares. So then we just simply have 5x minus 12 times 5x plus 12. Okay? For part C, you can already see that that is a sum of two squares. So the sum of two squares is just prime. That means I cannot factor. All right? For part D, okay, what's being squared? If I have a to the fourth, what is being squared? So remember, if I have an even exponent, you divide by 2. So 4 divided by 2 is 2. So the a here, I know it's kind of confusing, is a squared, and then the b is 3. So this would be a squared minus 3 times a squared plus 3. Okay, now I want you to pause the video. I want you to try both E and F on your own. Okay, so here's E and F, so just make sure, look over those, and make sure that you got the correct answer. So I'll just mention really quickly, make sure when you're looking at your exponents, so here we had a 6. To get that perfect, that square, you just divide. So 6 divided by 2 is 3 here. And then over here for F, we had exponents of 16 and 10. 16 divided by 2 is 8. 10 divided by 2 is 5. Okay? All right, so let's look at part G. And right off the bat, I see that I'm not subtracting, I'm adding two squares, so this is prime. Okay, so our final one is H. So 196, that was in the end of our list that we're looking at. That is 14. And then W to the 6th, 6 divided by 2 is 3. And then 225, that is the square of 15. So that's the first one, and then that's times 14w cubed plus 15. And that's really it, guys. That's how you find the difference of two squares.